This is very significant news. We know that our Milky Way galaxy is eventually going to collide with the Andromeda galaxy. Well, scientists are saying that the Andromeda galaxy's massive halo is already bumping into our Milky Way galaxy. And these are images from Hubble telescope by NASA ESA. Robert Gardner, NASA's Global Spaceflight Center, phys.org. This headline image illustration shows the location of 43 quasar scientists used to probe Andromeda's gaseous halo. These quasars are very distant, brilliant cores of active galaxies powered by black holes, and they're scattered far behind the halo, allowing scientists to probe multiple regions. Looking through the immense halo at the quasar's light, the team observed how this light is absorbed by the halo and how that absorption changes in different regions. By tracing the absorption of light coming from the background quasars, scientists are able to probe the halo's material. In a landmark study, scientists using NASA's Hubble Space Telescope have mapped the immense envelope of gas called a halo surrounding the Andromeda galaxy. That's our nearest large galactic neighbor. Scientists were surprised to find that this tenuous, nearly invisible halo of diffuse plasma extends 1.3 million light years from the galaxy, about halfway to our Milky Way, and as far as 2 million light years in some directions. This means that Andromeda's halo is already bumping into the halo of our own Milky Way galaxy. They also found that the halo has a layered structure with two main nested and distant shells of gas. This is the most comprehensive study of halo surrounding a galaxy. Quote, understanding the huge halos of gas surrounding galaxies is immensely important, end quote, explained co-investigator Samantha Barrick of Yale University in New Haven, Connecticut. She said, this reservoir of gas contains fuel for future star formation within the galaxy, as well as outflows from events such as supernova. It's full of clues regarding the past and future evolution of the galaxy, and we're finally able to study it in great detail in our closest galactic neighbor. She said, we find the inner shell that extends to about 500,000 light years is far more complex and dynamic. This is what also this lead author Nicholas Lerner of University of Notre Dame, Indiana said, saying the outer shell is smoother and hotter. This difference is a likely result from the impact of supernova activity in the galaxy's disk, more directly affecting the inner halo. A signature of this activity is the team's discovery of a large amount of heavy elements in the gaseous halo of Andromeda. Heavier elements are cooked up in the interiors of stars and then ejected into space, sometimes violently as stars die. The halo is in contamination with this material from stellar explosions. The Andromeda galaxy, also known as M31, is a majestic spiral of perhaps as many as 1 trillion stars and comparable in size to our Milky Way galaxy. At a distance of 2.5 million light years, it is so close to us that the galaxy appears as a cigar-shaped smudge of light high in the autumn sky. If its gaseous halo could be viewed with the naked eye, it would be about 3 times the width of the Big Dipper. This would easily be the biggest feature on the nighttime sky. Through a program called Project Amiga, Absorption Map of Ionized Gas in Andromeda, Amiga for short, the study explained the light from 43 quasars, the very distant brilliant cores of the active galaxies powered by black holes, located far beyond Andromeda. The quasars are scattered behind the halo, allowing scientists to probe multiple regions, and looking through the halo at the quasar's light, the team observed how this light is absorbed by the Andromeda halo and how that absorption changes in different regions. The immense Andromeda halo is made of very rarefied and ionized gas that does not emit radiation that is easily detectable. Therefore, tracing the absorption of light coming from the background source is a better way to probe this material. And we have the image here, a NASA ESA. The illustration depicts the gaseous halo of the Andromeda galaxy, if it could be seen with the naked eye, at a distance of 2.5 million light years. The majestic spiral Andromeda galaxy is so close to us that it appears as a cigar-shaped smudge of light high in the autumn sky. If its gaseous halo could be seen with the naked eye, it would be about 3 times the width of the Big Dipper, easily the biggest feature in the nighttime sky. Now, the researchers used the unique capability of Hubble's Cosmic Origin Spectrograph, COS for short, to study the ultraviolet light from the quasars. Ultraviolet light is absorbed by Earth's atmosphere, which makes it impossible to observe with ground-based telescope. The team used COS to detect ionized gas from carbon, silicon, and oxygen. An atom becomes ionized when radiation strips one or more electrons from it. Andromeda's halo has been probed before by Lerner's team. In 2015, they discovered that the Andromeda halo is large and massive, but there was little hint of its complexity. Now it's mapped out in more detail, leading to its size and mass being far more accurately determined. Previously, there was very little information, only 6 quasars with 1 million light years of the galaxy. This new program provides much more information on this inner region of Andromeda's halo. This is what co-investigator J. Christopher Hauck explained. He's also of Notre Dame. He said probing gas with this radius is important, as it represents something of a gravitational sphere of influence for Andromeda. Because we live inside the Milky Way galaxy, scientists cannot easily interpret the signature of our own galaxy's halo. Therefore, they believe the halo of Andromeda and the Milky Way must be very similar, since these two galaxies are quite similar. The two galaxies are on a collision course and will merge to form a giant elliptical galaxy beginning about 4 billion years from now. So that's basically way before our sun goes out. Our sun is going to be going out about 5 billion years from now. Now, scientists have studied gaseous halos of more distant galaxies, but those galaxies are much smaller on the sky, meaning the number of bright enough background quasars to probe their halo is usually only 1 per galaxy. Spatial information is therefore essentially lost. With its close proximity to Earth, the gaseous halo of Andromeda looms large on the sky, allowing for a far more extensive sampling. This is truly a unique experiment because only with Andromeda do we have information on its halo along not only 1 or 2 sightlines, but over 40, explains Lerner. This is groundbreaking for capturing the complexity of a galaxy halo beyond our own Milky Way. In fact, Andromeda is the only galaxy in the universe for which this experiment can be done now, and only with Hubble telescope. Only with an ultraviolet sensitive future space telescope will scientists be able to routinely undertake this type of experiment beyond the approximately 30 galaxies comprising the local group. Lerner said, so Project Amiga has also given us a glimpse of the future. The team's findings appear in August 27 edition of the Astrophysical Journal, and this was published August 29, 2020, so it's a 2-year-old article, but this is the first time I've seen this, and it's basically very important because of the fact that the halo is bumping into our own galaxy right now. And they estimate that in 4 billion years, we will have the collision. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.